Scripting for the Web, WS300 Platt College. The Document Object Model. The DOM is one of the most important concepts we have to deal with as web designers and developers. When we understand the DOM, how it works, and we understand HTML structure better, we can then apply CSS more effectively and create better JavaScript. The Document Object Model specifies how browsers should create a model of an HTML page and how JavaScript can access and update the contents of a web page while it is in the browser window. The DOM is neither part of the HTML or part of JavaScript. It is a separate set of rules that is implemented by all major browsers. 1. The making of a model of an HTML page, and 2. The accessing and changing of an HTML page. You will hear people talk about the DOM as an API. That stands for Application Programming Interface. Don't be scared of the use of the word or the acronym API because user interfaces let humans interact with programs. APIs just let programs and scripts talk to each other. The DOM states what your script can ask of the browser about the current page and how to tell the browser to update what is being shown to the user. So how a browser sees a web page. The browser receives HTML as just pure text, and then it interprets that and stores that information as a document object model. Each page on a website can be seen as a separate document, so the web consists of many sites which make up one or more documents. You can see this referenced on page 40-41 in JavaScript and jQuery by John Duckett, our class book. So here you can see a representation of how the browser stores the document in its memory. Here you can see the document, you can see the HTML, you can see the two children of the HTML tag, that would be the head and the body. Each of those have their own children. Each box is called a node. Each of these nodes is an object that we can access and manipulate with JavaScript. The three types of nodes represented here are elements, text within the elements, and attributes. When these objects are nested inside of each other, as we see in the case of the elements in this slide, the objects inside are called child objects. Remember, we talked about parents and children, we talked about HTML and CSS. This is what we are talking about, the DOM tree. It creates a new object for each element, and the text inside of our title and H1 tags, for example, is called a text node. The attributes in the link tag are considered properties of the link tag. Because of the way the browser sees HTML code as objects, it works like an array, and we'll get into arrays later. The body tag in this case has two children, H1 and the paragraph tag. The P tag has a text node and an EM tag. However, the text node is not seen as a child object. Your browser comes with a rendering engine. If there is no CSS, the engine will apply default styles to HTML elements as per the browser's chosen styling. However, the HTML code for this example links to a CSS style sheet. So the browser requests that file and then displays the page accordingly. When the browser receives the CSS rules, the rendering engine then processes them and applies each rule to its corresponding elements. This is how the browser positions the elements in the correct place with the right colors, the right fonts, and so forth. All major browsers use a JavaScript interpreter to translate your instructions into commands that the computer can follow. In an interpreted programming language like JavaScript, each line of code is translated one by one as the script is run. HTML structure: what items are nested inside of others, what items come next in the source file, etc. If your HTML is properly structured, tags closed, and so forth, your CSS and JavaScript will have no trouble in figuring out what element or part of the document object model you are trying to target to be affected by them. An example: document.body.children square bracket 0. The body is a child of the document. We can drill down into the objects that are inside of each other. This is what is called traversing the DOM. It is important for you to train your eye to see these things whenever you look at a page. What items might be nested within other items, and guess at the source order. Then look at the source order and see if you were right. So we already know what HTML source code looks like, and we can see how those elements are related to the document object model tree. Now we're going to take a look at DOM boxes. This is our page rendered with Ghost CSS. Ghost CSS is really good at showing where all the boxes are. No matter what an element looks like, it takes up a square-ish space on the page. Every element can be visualized as a box. Did you imagine that the beautiful rendered hotel had this simple box structure? I'll show you how to apply Ghost CSS in class. It's a great way to see margin and padding and any boxes that are pushing past your body element, giving you that weird horizontal scroll when you didn't expect it. When we add new elements to the live DOM, when we add, remove, or change classes of any elements on the page, attributes or properties, or the values of those things, these are all examples of document object model manipulation. Notice that I said live DOM. Your HTML source is the initial DOM rendered by the browser. The live DOM is what is seen when you inspect element. That live DOM can look different from the source code itself. Manipulation is reflected in the browser, not in the file served up from the server into the browser. Your JavaScript does not change the source, only the page as it is rendered. The DOM is automatically created in the browser. Through the DOM, we can manipulate our web pages, allowing us to show, hide, or reposition elements, and these things get updated in the live DOM.
That is the end of this lecture. I hope that this brings you understanding and enlightenment when it comes to programming, and I will see you in class.